So, problem number 2 says, find the theoretical oxygen demand for 200 milligrams per liter of acetic acid, which is CH3COOH. So the theoretical oxygen demand is the amount of oxygen required to completely use up all of your reactant. So you can think of it as a combustion reaction. So you have your acetic acid, and if we're going to find the theoretical oxygen demand, then we're trying to find the amount of oxygen right here to completely use up all this. So we were given 200 milligrams per liter of acetic acid. So we need to write a reaction to help us figure out the theoretical oxygen demand. So here's our theoretical oxygen demand right here. So the reaction, any combustion reaction, we know from general chemistry that a combustion reaction always yields carbon dioxide and H2O. That's just something that we understand. And then we want to balance our equation, so yes, gotta balance the equation. So we got 2 carbons here, 1 carbon there, so we need 2 carbons here. That gives us 4 oxygens, 5 oxygen. This gives us, never mind, I already balanced it right here. So let's see if this is balanced. This is 2 oxygen plus 4 oxygen, so that's 6. And this is 2 oxygen plus 2 oxygen, that's 4. So I need another 2. So I believe this is balanced. You can check that yourself. So now we need to write a chemical, or not chemical, we need to do stoichiometry is what it's called. So for stoichiometry, what we are focused on is comparing the molar coefficients. So all the coefficients for each compound, that's in moles. Like this whole equation or chemical reaction is in moles. So we need to use these molar coefficients to do any sort of comparisons. So, but what we're given is 200 milligrams of acetic acid. So we can start with that. 200 milligrams. Well, it's actually 200 milligrams per liter, but I'm ignoring the liter part. So it's 200 milligrams. But we need this to be in grams because all the molecular weights of our compounds are always given as grams per mole. Like, in oxygen there's 16 grams per mole. So if we have 200 milligrams of acetic acid, we need to change that to grams. So this 1,000 milligrams per 1 gram. And then yeah, for acetic acid, if you look up its molecular weight, the molecular weight of acetic acid is going to be 60.05 grams per mole. So we can use that value. So we go here to our stoichiometry. We have 60.05 grams of acetic acid per 1 mole of acetic acid. So this is good because we can get rid of some units, milligrams, grams go away. So now we have our 200 milligrams of acetic acid in terms of moles, which is what we want, because that's how we can compare our moles of acetic acid to anything else. And we're interested in how much oxygen we need. So for 1 mole of acetic acid, we have 2 moles of oxygen. So we go here and we say for 1 mole of acetic acid, we get 2 moles of O2. So this is good. This is really important because we're comparing our moles of acetic acid to moles of oxygen, because that's how you do comparisons with chemistry. And ultimately what we want to find is the amount of oxygen. So we do have the amount of oxygen in terms of moles, but what's more usable is to convert that to a mass. So then we say for 1 mole of O2, we get, that's 32 grams of oxygen. And then we do the math, which I will do. So that's 200 times 2 times 32 divided by 1,000 times 60.05, and we get this number, 0.213, and that's going to be in grams, because if we get rid of our units here, it's moles go away, moles go away, moles go away, moles go away. So all we have is grams of oxygen. So we have 0.213 grams of oxygen, which is also equal to 213 milligrams of oxygen. And that's going to be our theoretical oxygen demand. So it's not too bad. It sounds really fancy because it says theoretical oxygen demand, but really you're just doing like a basic chemistry analysis. And yeah, the main thing you really need to know is if it says theoretical oxygen demand, you need to know that you're trying to find the amount of oxygen to completely break up your compound, and your byproducts will always be carbon dioxide and water. That's like the biggest thing, because the calculations are pretty easy, but it's this part that is the most important, really. So yeah, that helps.